So, first of all, areas of parallelograms and triangles will be the first part of this lesson. So, areas of a triangle, we already know the formula for area of a triangle. You've known that for a long time. What I want to make sure you remember is that when you do the area of a triangle, the base has to be perpendicular to the height. Okay, so in this picture, you're shown, if this is your base, your height will be perpendicular. Remember, that's an altitude of the triangle. And you could use a different side as long as you use it perpendicular to that other side. Okay, and then for a parallelogram, let me highlight this one. For a parallelogram, the area is base times height. That's the same as a rectangle formula. Okay, so same formula as a rectangle for a parallelogram. So also the base is perpendicular to the height as well. So in a parallelogram, base and height are perpendicular. You're not multiplying the dimensions of the parallelogram, meaning you're not multiplying the base. If that's your base, you're not multiplying by the other side length. You're multiplying again by the segment that would go from the opposite side perpendicular to the side that you're using as your base. Okay, so we're asked to find perimeter and area of triangles and parallelograms. You can assume that that's a parallelogram if you see it. Round to the nearest tenth if necessary. Now, that's saying that if it's not necessary, then we're going to leave answers exact and simplified. Now, exact and simplified means no rounding. So that means leave your answers with fractions, decimals that are exact, radicals, but no rounding. Okay, so generally it's going to say things like if necessary from now on in terms of rounding, but you'll also see the term exact and simplified a lot. Okay, so that means that if you see problems that have 45, 30s, or 60s, you need to make sure you're not doing trigonometry. You need to treat those as special right triangles. Now, in a parallelogram, the opposite angles are congruent, so that makes that a 45-degree angle. So this triangle over here is a 45, 45, 90. Now, remember, that's important because we're going to do for area, we need to use base multiplied by height. Okay, and that would be your perpendicular there. So since the area is base times height, right over here, area is base times height, we need to figure out what the height is. So that means that in that triangle, this is a 45, 45, 90. So if that's your x, x is going to be 15 divided by the square root of 2, which is 15 root 2 over 2 after you rationalize. So our area is going to be base, which is 30, multiplied by 15 root 2 over 2. Now, remember, 30 is going to be over 1, so I'm going to go ahead and simplify that. So this will be 30 over 2 is 15, so that simplifies to be 225 root 2. And we're going to be careful about the labels. This is area, so it'll be in square feet. Okay, for perimeter, do we know enough to do perimeter? Yeah, this is going to be simple, so we'll just do different color here. We'll just do perimeter is the distance all the way around. So there's 2 15s and there's 2 30s. So that's 30 plus 60, which is 90. And again, that would be in feet. Please pay attention to the labels. Okay, perimeter and area. Now, when you see a diagram like that, I'm asking you to focus on the shaded area. So why would they have given you, this is the important part, why would they have given you that other little triangle out there? Well, the purpose of that is so that you can figure out what the height is. Okay, so in your triangle here, this will be your base, that would be your height, and we need to figure out what that height is. Okay, so in this little triangle over here, this is a right triangle, and that would be a Pythagorean triple. of 3, 4, 5. If you didn't remember that, you do the Pythagorean theorem. So that means that this height right there is 4. So the area of the, let me switch colors back here. The area of the triangle is going to be 1/2 base times height. I would like you to write the formulas as you're doing the problem, and that way I can see what you're thinking, and it'll also help you learn those formulas. So right now you don't have a lot of formulas. You already know triangles and parallelograms, probably, but it's just important that you kind of keep these in your head as you're going along. Okay, the base is 15, the height is 4, so it'll be 1/2 of 60 or 30. And again, that's going to be in centimeters squared. I'm going to pay attention to the fact we're doing area, so it's square units, and the label was in centimeters. Okay, for perimeter. Well, do we have what we need to do the perimeter of the shaded triangle? No, because we don't know that length. Okay, so I'm going to figure out that length by doing the Pythagorean theorem. So let's call that y. So 4 squared plus 15 squared equals y squared. 16 plus 225 is y squared. 241 is y squared, and y is the square root of 241. Okay, that does not simplify. So our perimeter is going to be 15 plus 4 plus square root of 241. And all that you can do to that is call it 19 plus square root of 241. And again, that would be in centimeters. Okay, triangle. Again, we're looking for the shaded area here. Why would they have given you that other little piece of the triangle there? Well, you need that in order to be able to do the problem. Okay, now for perimeter, sorry, for area, base there of the shaded triangle, what's the height? It's not that length, okay? And you also want to make sure you're not using this whole thing. So area to find the area of the shaded triangle, the base is 13, the height is actually 9. Okay, so this is the altitude of an obtuse triangle, which means it's going to lie outside. So the area for the triangle, 1/2 base height, we're multiplying 13 by 9. Let's see, 13 times 9 divided by 2, 58.5. That's exact, so I don't mind there being a decimal there because it's exactly 58.5. I don't want you to round, but if it's exactly a decimal, that's okay. All right, for perimeter, what do we have to know that we don't already know? Well, let's see. We're going to have to find this side, which I'm going to call X, and then we're going to have to find this side, which I'm going to call Y. Okay, so for Y. So for X, well, this is an isosceles right triangle. So X is going to be 9 root 2. It's a 45, 45, 90, so 9, 9, 9 root 2. Okay, for Y. Now, the easiest way to find Y would be to use the large right triangle. So if we look at this triangle here, Y is the hypotenuse of that right triangle. Okay, so we're going to do 9 squared plus this length is what, 22 is equal to y squared. 81 plus 22 squared is 484 equals y squared. 565 is y squared. Okay, let's divide that by 25. Oops, not 25. Let's divide that by 5. And that is not going to break down either. So y is just the square root of 560, square root of 565. So the perimeter of the shaded triangle would be 13 plus 9 root 2. That's this side, remember. and then plus square root of 565. Now, do any of those break down? I mean, do any of those combine? No, because to add, you have to have like radicals. So nothing you can do to that. That's your final answer. Okay, 13 plus 9 root 2 plus 565, square root of 565 centimeters. All right. Notice that this is actually a rhombus because all the sides are congruent, and they told you the directions that this would be a parallelogram. So in opposite angles are congruent, which means this is a 30, 60, 90 triangle. Now, since the side length is 24 on the bottom here, and it's a rhombus, that'll make this hypotenuse also 24. So since that's the hypotenuse, that makes the short leg 12. It makes the long leg 12 root 3. So again, reminder here, you'd have, this is your 2 side, this is your 1 side, this is your root 3 side. Okay, so for area. Okay, for area, it's a triangle, so 1/2, sorry, it's a, not a triangle, it's a parallelogram. So base times height, so that'll be the base is 24, the height is 12 root 3. So 24 times 12, 288 root 3. Inches squared. Okay, and the perimeter is super easy. So the perimeter is just 24 times 4, which is 96, and that would be in inches. Okay, so that is finding areas of perimeter and areas of triangles and parallelograms using special right triangles and leaving answers with radicals in them. So that's called exact and simplified. Sometimes you'll end up with a decimal like on this problem down here, but that's still an exact value. So it wasn't necessary to round to the nearest tenth. Okay, so again, when it says if necessary, that means if it was not, like if I had a 48-degree angle here or something where I couldn't do a special right triangle and I had to do trig, then that would be a rounded value. So the first thing you always want to try is to use special right triangles. Okay, next part of this lesson. Trapezoids, rhombuses, and kites. Let me change some colors here. Okay, so trapezoids. The area of a trapezoid is 1/2 times the height times the sum of its bases. Okay, 1/2 times the height times the sum of its bases. So 1/2 times the height, which is the perpendicular distance between the two bases, and then the sum of the two bases. Now, remember, if you did 1/2 of base 1, this is down here, if you do 1/2 of base 1 plus base 2, that's equal to the mid-segment. The mid-segment is half of base 1 plus base 2. So another way to think of it is an area of a trapezoid is the height times the mid-segment. Get the right height there. Height times the mid-segment. Okay, so that's formula for a trapezoid. And then for a rhombus and kite, it's 1/2 the product of the diagonals. The area of a rhombus or a kite. So they're different shapes, but they do have the same formula. Both of them are comprised of right triangles, and that's why the formulas end up being the same. So recall the diagonals of kites and rhombuses are perpendicular. So in a kite or a rhombus, you find the length of the entire diagonal, multiply the entire diagonal length, and then take half of it. Okay, 1/2 of diagonal 1 times diagonal 2 is area. Okay, so on a kite, the diagonals are not perpendicular, remember that? But you'll still multiply, sorry, I don't mean they're not perpendicular, they are perpendicular. The diagonals are not congruent, so be careful on rhombuses and kites both. These two will be the same, the diagonals bisect each other, and these two are the same, the diagonals bisect each other. Okay, this one's a rhombus. In a kite, remember that one diagonal is bisected, so the short one is bisected by the long diagonal. The long one is not bisected, so it'll look like that. Okay, so just kind of a reminder about the properties of those. Now, what I'm telling you down here is you can always break this into right triangles, find the area of one of them multiplied by 4 for a rhombus. Okay, you could find the areas of the triangles to find the kite. I would not do that. I would just try to use the formula. It's going to be faster most of the time. Okay, area of the trapezoid. All right, so first of all, area is 1/2 the height times base 1 plus base 2. So let's figure out what the base lengths are. So this one, that's vertical, so we just count it. 1, 2, 3, 4, 5, 6, which also makes sense because we're going between a height of -2 and a height of 4. So that distance is 6. Okay, this one, we can count 1, 2, 3, 4, or just notice we're going between -1 and 3. So that's a height of 4, or length of 4. And then our height of the trapezoid needs to be the perpendicular. It's not that side because that side's not perpendicular to the bases. Okay, and this height is also 4. All right, so 1/2 times the height, which is 4, multiplied by the sum of the bases, 4 plus 6. Now there's a 1/2 there. If I do half of 4, you get 2, and then 4 and 6 is 10, so that would be 20. And the label would just be units. It's not any particular thing. It's just these little boxes, whatever those little boxes are. Okay, units squared. I only asked you to find the area this time. I didn't ask you for the perimeter. We could do the perimeter. It's just going to be a little bit more work because you have to do the distance formula to find those leg lengths. And I don't want to mess with that right now. Okay, same thing with this kite. It says find the area of the kite. And so we're looking for 1/2 the product of the diagonal. So we need to know how long is that diagonal, how long is this diagonal. Now remember, they're also perpendicular. So for that one, that is starting at 0, going to 6. So 1, 2, 3, 4, 5, 6. It's not surprising. This length is 6. Okay, and then this length, it would be better if I did this. It would be better if I did, that is 6. And then that is, what, 4? 1, 2, 3, 4, yeah. 6, between 6 and 2, so that's 4. And then we can do 1/2 d1 times d2, which is 1/2 of 6 times 4, or 1/2 of 24, which is 12, and that would be in units squared again. Okay, and then lastly, I'm telling you this is a rhombus. We know that because it's got 4 congruent sides. Any quadrilateral with 4 congruent sides is a rhombus. Could be a square. This one is not a square because the lengths here are not the same. Okay, so in order to find the area, we just need to do 1/2 the product of the diagonals. This whole diagonal here is 14. The whole diagonal there is 16. Okay, so the area is going to be 1/2 diagonal 1 times diagonal 2. 1/2 of 14 times 16. 14 times 16, 224. which would be 112, and that would be in meters squared.